Hi everybody, myself Halavat Ramesh. Welcome to my YouTube channel. Especially today we will talk about very simple topic, green chemistry. And this is very important, especially in theory parts and the research also it is very important. And nowadays this is the one of the sustainable topic, especially in green chemistry. So today our discussion part is about green chemistry. What are the basics and fundamental and principle, and what are the some green reactions we will discuss slide by slide today. So you can see the first one, what is green chemistry. So in green chemistry, the design of chemical products, whatever it is, any processing to reduce or eliminate the use of or generation of hazardous substance. So green chemistry applies a across the life cycle of the chemical products, including its design, manufacturing, use and ultimates. So that is the main concept of green chemistry. So green chemistry, if you design the chemical products or process that to reduce or eliminate the use of generation of hazardous substance. So green chemistry should applies across the life cycle of chemical products, including its design, manufacturing, use and ultimate. So that is the main concept of green chemistry. And you can see the green chemistry also called as a sustainable chemistry. Oh, and it is design of chemical products and a process that reduce or eliminate the use or generation of hazardous substance. So the concept integrates pollution and prevention or process identification approach at laboratory or industrial scales to improve source efficiency or minimize waste or risk across the life cycle of chemical or materials. And you can see here the green chemistry is similar to the substance chemistry or circular chemistry. It is the area of chemistry the chemical engineer focus on the design of product and process that minimize or eliminate the use or generation of hazardous substance. While environmental chemistry focus on the effect of polluting chemicals or nature, green chemistry focus on the environmental impact of chemistry. So including lowering the consumption of non-renewable source and technological approach for preventing pollutions. So now you can see some principle it should be covered into that green chemistry. So the first one point you can see the design of process to maximize the amount of raw materials that end of the product. So that point is the main concept of the green chemistry. And second one point, the use of renewable material, feedstock or energy sources. The third one point is use of safer environmental maintenance substance, including solvent, whenever possible. So next one point is the design of energy efficient process. Next one, the avoiding the production of waste, which is viewed as a ideal form of waste management. So these are the some basics principle of green chemistry. Now coming to the 12th principle of green chemistry are very important. So that there is the green chemistry is established like one 12 principle methods. Those should be followed as a green chemistry. So what is the first one? The out of 12, what is the first one? Prevention. So the first one is a prevention. Preventing the waste is better than treating or cleaning of the waste after it is created. So when any reaction if you are doing, some byproduct will come out, it should be clean up and reuse. So that is the main first principle of the green chemistry. And the synthesis of the chemical compound should give as possible no waste, or simply you can no byproducts at all. So these waste or byproducts may pollute the environment. So the first one is prevention of the byproduct, or simply called side products. That is the first point. And second one point you can see atom economy. So synthetic methods should be tried to maximize the incorporation of all the materials used in the process into the final product. It It is said that if in any synthesis the yield of the product is 90% or above, the synthesis process is good. Suppose you can see the percentage of yield is called practical yield of the product by theoretical yield of the product into 100. So if in the reaction of the mole ratio of the reactant and product as per the stoichiometry equation, the product yield should be said to be 100%. That is called atom economy. So atom economy means the theoretical product and the practical product should be reached to the 100%. Simply we will call there is no completely byproduct. So that is called atom economy. Now coming to that third one point, the less hazardous chemical synthesis, or simply we will call the prevention or minimize the of hazardous product. So that is also very important. So you can see the synthesis methods should be avoid using or generating substance toxic to human or in the environment. This process is the basic idea of green chemistry. So the toxic or environmental harmful effects of hazardous products are controlled by the workers are wearing protective cloths by using mask or using engineering control methods. So all these processes are expensive. So then a scientific answer should be overcome this effect of is essential. And the fourth one is designing safer chemicals. So chemical products should be designed to achieve their desired function while being is a non-toxic as possible. So the energies required should be minimum as possible. The use of catalyst energy supplied through the photochemical useful, like photochemical reaction. Why? Because the sunlight will be used as a catalyst to control the entire reaction. So now we can see the fifth one principle, safer solvent and auxiliaries, like designing safer chemicals for the same use. So auxiliary substance should be avoided. Therefore, the possible that non-hazardous or the possible when the must be used. So the example of thalidomide, you can use the pregnancy lady they are using, but they have the side effect. So this kind of problem should be overcome as a green chemist for the next two. Next one you can see here, the sixth one, the design for energy efficiency, like selection of solvent used in the solvent reaction. So energy required should be minimized or the process should be conducted at the ambient temperature or whenever possible. As for the possible of solvent should be like water is no toxic. So water does not cause any environmental pollution or health hazards. So this water used as a solvent kind of reactions you can implement as a green chemistry and you can follow as the green chemistry principle. So sometimes the selection of the immobile solvent advantage, like sometimes that is achieved by the binding of solvent molecules, the polymer chain. So polymer solvent are also useful. And seventh one principle, use of renewable feedstock. So whenever the practical to do some renewable feedstock, raw materials is preferable for non-renewable ones. And next one, eighth one point is the eighth one principle, reduce derivatives, like productive of reactive groups. So unnecessary generation of derivatives such as the use of protecting groups should be minimized, as avoiding the possible such steps required additional reagents or may generate additional waste. And suppose that the given reactant has two active groups that can participate in the reaction, but we want only one of them. So to do so, then we have to protect the other group till the reaction is completed. So after reaction, the protecting groups should be removed. So these kind of reactions, this kind of you should be important for future generation of green chemistry. Now coming to the ninth one principle of selection of proper standing materials. You can see the catalyst reagent that can be used in a small quantities to repeat the reaction has supply and stoichiometry reagents. So one that can consume in the reaction. So if the catalyst used in a reaction, it offers several advantages. Catalyst is has a recovered after the reaction, possibility for better yield. So the reaction takes place at higher rate. So what here is the main concept? The green synthesis help to maximize use of starting materials and negligible waste byproduct formation. That is the main principle of the green chemistry. Second one, like 10th one, design for degradation or preparation of biodegradable products. So chemical products should be designed so that they do not pollute the environment. So when there is a function is complete, should be break down and into the non-harmful product. So these kind of reactions will make a for green chemistry principle. Now we can see the 11th one. So 11th one principle is here the real-time catalyst or real-time analysis for pollution prevention, like design the proper plant or reactors. So toxicity, explosive, fire, etc. It must be prevention by the designing of plant structure carefully. So analytical methods needs to be further development of permit real time in process monitoring or control before the hazardous substance form. And last one is inherently safer chemistry for accident prevention. So process development. So whenever the possible that substance in the process and the form of those substance should be close to minimize risk such as explosion, fire and accidental releases. So industry's chemical process is to be designed such a way that consume minimum chemicals and recycling the unreacted reagent for reuse possible, and sensors are to be accurate to monitor the whole process of the hazardous byproducts for advantages. So these are the 12 principles. You can see simply we will be understood what are the green chemistry pocket guidelines. So this is the 12 principle of green chemistry. You can see here the first one point, prevent waste, second one atom economy, and third one is the less hazardous synthesis, fourth one design binning chemicals, and fifth one binning solvent and auxiliaries, and sixth one design for energy efficacy, seventh one use of renewable feedstock, eighth one reduce derivatives, and ninth one catalyst like stoichiometric, 10th one design for degradation, real-time analysis for pollution prevention, and last one inherent beginning chemistry for accident prevention. So these are the 12th principle of our green chemistry. Now we can see the chemistry of nature. So green chemistry is like final, it's the design, development and implementation of chemical products, the process that reduce or eliminate the use of generation of hazardous substance. So this is some basic principle of green chemistry. You can see here the green chemistry also one of the basics, what are the safer solvent, how to use and how to prevent, and these are the some examples I mentioned here the green chemistry. And you can see here what is the green chemistry, how to go for the vegetable catalyst. So nowadays the green chemistry using for the vegetable catalyst some few reactions. So biocatalyst, enzymes, plant extracts of nanomaterial synthesis, these all comes under the green chemistry. Now we can see natural dye extraction and application. Nowadays food industry, they are bulk using artificial food color in cosmetic industry, pharma industries, many industry. But the natural dye color industries extraction from the plant and you can use for the green chemistry. Next one, biocatalytic reduction. This is also one of the basic principle of green chemistry. Now we can see waste derived solid catalyst. So you can see this is principle, and you can see the carrot waste. So nowadays carrot also used as a for green chemistry for the ketones. So biocatalyst reduction of ketone using carrot and whole cell biocatalyst. So the most prominent green chemistry is carrot vegetable roots or whole biocatalyst in organic synthesis, ketone reactions, ketone based reactions. And you can see here beetroot also using here for the green chemistry, and I can see many like groundnut, vegetable oils, potato, peanuts, cauliflower and cucumber, tomato, pepper, they are using in green chemistry. Now red cabbage, beetroot, spinach, broccoli, many and non-eatable green chemistry is also nowadays using for biodiesel production, Jatropha and other kind. You can see many Indian aromatic plants are using for the green chemistry. You can see